Okay, so let's talk about. Um, let's start with the topic quantum mechanics, and we'll be talking about. Okay, so uh, let's talk about today. We'll just talk about general quantum mechanics. Like there's no specific topic today, so we can start with the general idea of quantum mechanics. Now, the general idea, or like what quantum mechanics really is that it's the study. Well, the definition itself is that if we talk about the definition, everyone has their own definition. It can depend word to word, but if the concept is same, it will that doesn't play any effect. So it's about study of nature of nano for like small at atomic levels, nano level atoms and particles. It would be better if I say particles because atoms are bigger than particles. So it's but because particles are in a nano scale or nano level. Okay, which is 10 power minus 9. That's way too less. And uh, so then, how about this equation E equals HF, one of the one of the basic or the starting equations which are taught when quantum mechanics is started, when someone starts learning quantum mechanics. So this equation shows, actually this equation is the equation form of photon. This is specifically for photon and other particles as well, but if we want to define photon as equation, we just say hf. This is the energy which photon consists. What is h? We all know that h is a constant made by Planck, known as Planck's constant. And f here, f, or in some areas, f is also written as v, which stands for frequency. For some people, they write frequent V. Now, it's a Greek symbol. Now, uh, F here is frequency, and we know that photon is a gamma light, is a gamma wave. Gamma wave. Now, it being a gamma wave shows that it must have high frequency. High frequency. Now, what does it mean by it having high frequency? Okay, let's calculate the energy. Let's suppose we'll do some calculation based on say basic assumptions. I will be making assumptions, and on those assumptions we will be making calculations. Okay, now imagine that since it's a gamma, its frequency is higher. Let's suppose if we have light of 6 m hertz, mean 6 megahertz, mean 6 times 10 to the power 6 hertz. Okay, light vibrating of a frequency this. Now what will be its energy? Energy will be hf is what? H is 6.626 times 10 to the power minus 34, and h is uh, 6 megahertz. Now what we get if we can do the calculation, the calculation we get is 6.626 times 10 to the power minus 31, sorry, 34, and this times 6 times 10 to the power 6. Well, my calculation does give me a value, and it's nearly 3.97 times 10 to the power minus 27 joules. Now, some people, even when I first looked at this value, I thought it's not possible for photon to have this much value, because mostly whenever we are doing whenever we are doing calculation, and generally we get energy between minus 18 to minus 19, but it is possible for photon to be this low. Possible value, possible value. So it's not a problem if we get this value. Now, uh, this is energy of in these multiple uh, areas or states. Sorry, I forgot the word states. Okay, now states mean states, or if I further expand the states, what I'm trying to say is x and t state 1 plus state 2 plus state 3 and so on, and it doesn't stop, it just keeps on moving because it has multiple and in terms of graph. Oh yeah, one more thing, uh, and yeah, one more in terms of graph I meant by when I was in terms of graph, one more important thing is that when we try to make it physical value, physical quantity, there's something important we should know, that that the